OK, let's talk about really fun stuff. This came up, actually, some students asked me about this earlier, and I said, we'll be covering this really soon. Single sign-on and third-party authentication. So it's easy to motivate this problem. A few years ago, the New York Times had this neat functionality that all of a sudden turned on one day, and you could see what articles your Facebook friends were reading and liking in the New York Times. So suppose you wanted something like that for Rotten Potatoes. In the New York Times example, it meant that somehow the New York Times website is able to access your Facebook information, like who your friends are and what they were reading. But clearly, you don't want to be doing this by revealing your Facebook password to the New York Times site. So as a general rule, even though you want sites to possibly be able to share information about you with each other for your benefit, you don't want to do this by revealing your login information to different sites, right? And the canonical example here is you would never reveal your login information about your bank account, even though you might find it useful for some other applications to have limited access to some of that information. So the way that we handle this case, which is increasingly the way that authentication is done today, is we use third-party authentication. So let's make sure we understand some building blocks of how this works. The first building block is what's called a tamper-evident secure token. Tamper evidence just means that there's a string that I can create that if you try to tamper with it by perturbing a few characters, it will essentially become an invalid string. It'll become unusable. And the way I do this is I can create a string that, because there's a secret that only I know, it's a string that only I can decrypt. I'm the only one that can make use of it. I can also detect if it's been tampered with, because if you tamper with it and I try to decode the tampered version, it won't decode properly. So I can basically create it in such a way that unless it decodes to have some specific fields and formats, I can tell that it's been tampered with. And because I created it by using a secret that only I know, presumably nobody else could have created a string like that unless they somehow got a hold of my secret key. And in most cases, the string really is just a handle to other information that I'm storing. So the string doesn't necessarily contain the interesting information. It contains enough information that I can store the state locally and retrieve it later. A simple thing you could imagine it containing is I'm storing that information in my database, and the string encodes like the primary key, let's say, of a particular database row corresponding to the information about a particular user. So how do we use this capability? We're going to use an example of connecting Rotten Potatoes to Twitter. And after we explain this, I'm actually going to do a code walkthrough to show you how it works. I actually have connected Rotten Potatoes to Twitter. It was easy. So here I am. Here is my pet toucan, who sadly is no more. But during the time that I wrote the book, she actually supervised a lot of the writing, as you can see. And I want to be able to use my Twitter account information to log into Rotten Potatoes. So how do I do that without revealing my Twitter password? The first thing is I let Rotten Potatoes know that I want to log in with Twitter, which causes Rotten Potatoes to essentially send me back a redirect, which sends me over to Twitter. So this is an important concept, because I'm about to type in my Twitter credentials, but I'm not typing them into Rotten Potatoes. I'm typing them only into Twitter. Presumably, I can trust Twitter with my Twitter password. And Twitter can then present a page to me saying, Rotten Potatoes is asking if it can access your information. Is that OK? And it's not revealing what my password is. It's just saying, this particular user signed into this other application, Rotten Potatoes, wants to use your Twitter information. Are you good with that? Assuming that I am good with it, and I'm saying, yes, that's fine, give all my personal information, let it tweet as me, do whatever you want, Twitter will then redirect to a callback page, and it will provide an access token that was created according to the guidelines that we just talked about. So what are those guidelines? It's created based on a secret that only Twitter knows. The token encodes information about what I said was OK to do. So the information is formatted in such a way that if Twitter is ever handed back that token, it can decrypt it and verify whether the thing that Rotten Potatoes is trying to do on my behalf is one of the things that I agreed to. Right? So that's why a tamper-evident container is so important. And at that point, whenever Rotten Potatoes wants to do something on my behalf on Twitter, it basically presents the token and says, look, here's the proof. Right? You made this token. No one else could have made it. Here's the token that presumably proves that this user said it's OK to act on their behalf on the Twitter site. Right? That's the basic flow for third-party auth. And once Twitter has done that, it can, for example, get my username or my screen name from Twitter and start to personalize my screens using that information. So this is kind of a simple example of third-party authentication. But this flow is basically how it works for all sites. One of the more popular protocols now used for this is called Auth. It's kind of in its second major version. The bad news is Auth is pretty hairy. The good news is that there's a gem that makes it really easy to use, as I'm about to show you. So how do we actually put this into our application architecture? The idea is pretty neat. You actually model a session as its own entity. So if you think of a session beginning at the time that I log in and ending either with me logging out or with it timing out, like my abandoning, then we can think of a session controller whose job it is to create and delete the session. And that's where we can centralize the logic that's going to negotiate with the remote service and try to act on my behalf. Now, once the user has been authenticated, we still need some local representation of who that user is. So the most common scheme is that you use the session to remember the primary key of the authenticated user. And remember that Rails also uses tamper evidence techniques to create the session. So it's not as if you can grab the session and stick a user ID in there and be logged in as that user, right? You'd have to be able to tamper with a tamper evidence string in order to fool the session into carrying around your information. We're going to show an example in a moment using the OmniAuth gem, which provides a uniform API from your app's point of view and has strategies for talking to many different backend authentication providers. An auth provider is basically any service that has information about you and wants to allow an external service to act as you. Twitter is an example. Facebook is an example. Google is an example with Google Apps or Google+. Other examples abound. GitHub is an example for that matter. So before we do a code walkthrough, let's do a sanity check here. Which is true regarding third-party authentication between a requester and a provider? So the requester in our example was an app like Rotten Potatoes. The provider is the place where the authentication info actually lives. In our example, that was Twitter. So which statement is true? Once completed, the requester can do anything that you could have done on the provider. So Rotten Potatoes can do anything that you yourself could have done when logged in to your Twitter account. If your credentials on the requester are compromised, in other words, if the Rotten Potatoes credentials or Rotten Potatoes database is hacked, then your credentials on the provider, i.e. Twitter, are also compromised. If the provider revokes access, in other words, if Twitter says no more, the requester, Rotten Potatoes, no longer has any information about you. Or access can be time limited so that it expires on a preset date. That, for example, one response from Twitter to Rotten Potatoes could be, yes, you can have permission, but only up until this long. After that time, I'm going to revoke it, and you'll have to re-authenticate. So which is true?